Hi, my name is Mohan Poteri. I'm a staff solutions architect at VMware, and today I and my colleague Sudhir Balasubramanian, who's a senior staff solutions architect at VMware, are going to present to you this topic: pure storage and vVols, a game changer for database as a service. Let's move to the agenda. So why vVols is the first topic we'll look at. Then we'll look at why vVols and how vVols is a game changer for database as a service. And then we will conclude. Why vVols? Each LUN volume has a specific capability. When a LUN or volume is provisioned, it is set up with specific features or capabilities. It requires a data store per capability. Changing the capabilities of an existing LUN or volume requires migrating VMs to another data store. Changing is very arduous. It is very hard. To change an existing capability requires destroying and recreating LUNs and volumes, which is very difficult to do. So to provide incremental operational management, you require, you actually have to, like you see on the side here, spreadsheets to manage your environment. That's how traditionally things are done. But vVols can change all of this. So if you look at LUNs or volumes, they are pretty rigid and are fixed in capabilities. They also require a file system such as VMFS or NFS. With vVols, there is no file system. It's inside each vVol that a file system is created, and that file depends on the OS or the vVol function. With regards to the capabilities, generally a LUN or volume is provisioned with a specific set of capabilities, and that isn't easily changed without creating a new LUN or volume. With vVols, changing the capability is simple. With the simple change of what we call is a policy, storage provision policy, right? The capability is changed and no storage vMotion or data migration is required. Depending on the array, you can actually change from spinning media to all flash with just a policy change. The array then handles the performance and the data migration. No admin action is required. Imagine that. Another key aspect of vVols over traditional storage is that the array and vSphere has complete insight into the data and IO requirements. The array will manage all of these rather than vSphere, like in the legacy environment. So it's managed in a much better way. So now let's look at storage policies and how they help here. By utilizing storage, what we call SPBM, to manage the storage, the need to physically migrate virtual machines to different data stores to get different capabilities is no longer needed. By changing a policy, the VM will get the new policy, new capabilities from that policy. So even things like replication and other performance capabilities that you would need are automatically available through the policy change. When the VM policy change, for example, is changed to production, the VM is automatically replicated to, and whatever policy that the production requires is automatically applied for the VM. So that's, here we see a lot of different things that we can do. Every VM has its own different capabilities, and we are not really changing anything with the array. Everything's happening with vVols. We are just, we are able to kind of have all these VMs operate at different policies, sharing the same storage. One other important aspect, because the array owns the vVols and its capabilities, such as snapshots, clones, replication, it is much faster. It is much more efficient because there is no intermediary. The array does all the work. vSphere just passes the all the functions and the responsibilities directly to the array. So things like clones and snapshots, which kind of vSphere used to do it, on its own accord is now done by the array. And it exploits native capabilities such as instant deletion. It provides inherent space efficiencies. Policy changes can also be easily integrated. You can have both storage containers and LUNs simultaneously. All policy changes are happening behind the scenes, and you can also apply QoS and other policies on the fly. So now we'll just look at how snapshots work in traditional VMFS versus how it operates in vVols. With traditional storage, snapshots are managed by vSphere. Although vSphere is efficient with snapshots, arrays are much better at doing that job. With typical VMware snapshots, a secondary sparse disk is created and all new IO goes to that disk. If this disk is not removed, it can continue to grow even larger than the original disk. And if more snapshots are created, more chains are created, as you can see in the animation in the left-hand side here. So consequently, performance of the VM can be impacted because now the IO is spread across multiple VMs, multiple disks attached to a single VM. This is the norm, but and it can be quite a bit, and it also takes a lot of time to delete. When a snapshot is created, it happens instantaneously. But when you try to delete the snapshots, it takes a long time because it has to clear out all these disks and the redo logs and other aspects, and it could take many hours to delete. And at those times, the VM could be impacted for performance. So now let's look at how the same thing happens in the vVols side. With vVols, the snapshots happen on the array. And the array-based snapshots are point-in-time pictures of the data and take very little space. When a vVols snapshot exists, the IO is not redirected and instead continues to go to the same disks on the vVol. Leaving a vVols snapshots alone will not continue to grow and can be copied to another array and even used as a copy to clone from the original. When a vVols snapshot is deleted, the snapshot is quickly removed with no impact to the VM. Regardless of how many snapshots are part of a VM, there is no performance impact on the VM. That's a huge difference here. So another important aspect is that vVols make replication really easy. So with VMware Virtual Volumes, introduce the concept of replication groups. This brings accurate and responsive recovery of individual virtual machines. A replication group is a group of replicated storage devices that are defined by the storage administrator to provide atomic failover. That means you can choose a subset of VMs or apps that fail over together, and that's kind of how you provide atomic failover. In the past, in the traditional legacy world, it is very hard to do. Replication groups also define the set of vVols that are maintained in a write order fidelity, where writes are replicated on the same destination site in the exact same order they're generated at the source site. This ensures that anytime the destination site represents a crash consistent copy of the data on the source site. So you can have multiple policies, and based on those policies, replications could happen to the remote site. Now I pass it on to Sudhir to talk about vVols for DB as a service.
Thank you, Mohan. Next slide, please. All right. So let's first understand what DB as a service actually means, right? Essentially, it's the ability to manage, monitor, and provision databases resources on demand through self-service catalogs with minimal requirements for installation and configuration of hardware or software upfront, right? So the idea is to allow database consumers, such as application developers, such as DBA, such as testers, the architects, the owners, to provision databases easily and quickly using what's called an on-demand self-service platform, right? So what essentially are some of the benefits of DB as a service? What happens is the application time, right? So there's a reduction in the application time to market. What DB as a service gives us is the ability to rapidly develop, test, and deploy new applications at a fraction of the time it used to take with legacy systems. So now it's easier, now it's faster, a time to market the new applications, right? The second benefit that actually comes into mind is automation of database lifecycle management, right? As we all understand, database sprawl is a major problem in many companies. It's very difficult to keep track of all the database instances that have been deployed. And this has serious repercussions. This has serious implications, not only from licensing perspective, also from data governance and also from security standpoint. With DB as a service, one can ensure that we have complete visibility into our database environment. We are able to enforce that governance through policy-based management, right? Another benefit of database as a service essentially is you're able to increase the operational efficiency and resource utilization, right? So database as a service increases the efficiency of both your database application and also the infrastructure team. What here happens is the storage administrator will no longer need to spend time and effort on provisioning storage resources for databases. On the other hand, DBAs will no longer have to wait for DB resources to be allocated and provisioned. So essentially, we are now freeing up time for both of the teams, right? So if you look at the slide here, some of the use cases of database as a service that essentially comes to our mind could be like defining templates of Oracle DB VMs to be available in a self-service catalog. You're able to commission, you're able to decommission single instance Oracle RAC from that self-service catalog. You can clone databases, you can refresh databases, you can back it up, you can restore, you can add, you can remove nodes to an Oracle RAC cluster on the fly. You can even have some kind of metering, you can have some kind of reporting as well, right? So, besides all this, an important factor that comes in my mind that we have to keep in mind is oftentimes what happens is the storage performance is the limiting factor that hinders database as service projects. So traditional disk-based storage that cannot meet performance need for DB as a service, and it's inherently too complicated to manage, right? So DB as a service, what it requires, what it entails is high performing storage infrastructure to ensure rapid provisioning of databases. You need to have efficient data reduction to ensure storage capacity is not exhausted, right? We need to have a high degree of resilience to ensure minimal to no downtime. And of course, DB as a service, you need to have what's called the ease of use and maintenance and management as well. Next slide, please. All right. So having looked into what DB as a service is, and having looked into what database as a service requires, right? And we also looked at some of the potential use cases. Let's now change tack and look at some of the requirements that business critical workloads they have, right? So any business critical workload, Oracle is no particular in this sense here, right? They have certain SLAs, they have certain RTOs, they have certain RPOs, and they have a set of stringent requirements. And those requirements include high availability, performance, recoverability, scaling up, scaling out, essentially scalability, security, so on and so forth, right? And these are strict requirements for day two operation, also to complete in a timely fashion. For example, if you have your backups, you have your cloning operation, if you have your refresh operations, you want to make sure that these operations complete in a timely fashion so that they don't affect performance. They are within the SLAs for that particular application, right? So what happens is with virtualization of Oracle workloads, customers, they have certain concerns. And some of the concerns include, well, different databases have different levels of criticality. They require different storage performance characteristics and capabilities. Well, I would need to meet stringent SLAs for performance, right? And that's a challenge, especially with slow traditional storage, right? The other thing that comes in our mind is, with rapid database growth, what happens is there's a need to reduce backup window to meet the performance in business SLAs, right? And especially with these large database sizes, what then happens is there's difficulty in cloning. There's difficulty in refreshing data from production to QA or any other environment for, let's say, testing or for patching purposes, right? And again, last but not the least, using storage-based replication, as everybody understands, right? With storage-based replication, it's very superior as compared, when you compare it to application-based replication when it comes to speed. But then what happens is you also get unnecessary data. And that unnecessary data is the VMDK of other databases that you do not want to copy as part of the storage-based replication. Next slide, please. So I'm not going to go into deep dive into the vVol architecture, but we'll see how we are able to overcome some of the challenges that we posed in the earlier section here. So, we had this concept of SPBM, and Mohan spoke about it, the storage policy-based management. Well, that essentially is a storage policy framework that helps administrators to match the VM workload requirement to storage capabilities. So what happens now is SPBM runs as an independent service in vCenter, right? And it helps to align the storage with the application demands that every workload has. Right? What SPBM does, it enables the following mechanism. It advertises the storage capabilities, as Mohan said. It advertises the data services offered by storage arrays and other entities, right? It also facilitates the bi-directional communication between ESXi and vCenter on one side, right? And storage arrays and entities on the other side, right? And what happens is it helps with virtual machine provisioning. You're basically using what's called the VM storage policies, right? The other thing to keep in mind is with vVol, not only do we get storage-based replication with superior speed, we also get what's called the VM level granularity. As I mentioned before, the level of granularity is no longer on the LUN. It's no longer on the data store side. It's more on the VM side, right? So that becomes a unit of storage management, right? And now, since all of the VMDK, so the virtual disk or the VMs are now vVol based, operations like cloning, operations like backup, refreshes, restore, they become blazingly fast because they are all storage-based operations, right? So the DB growth, which was a concern before, that's no longer a concern now, especially from a performance or an SLA perspective. Next slide, please. So to wrap up as part of the conclusion, right, with databases service using virtual volumes, right? We understood as to how business critical databases, they typically are among the last of the workloads to be virtualized because of the challenges, as we know, posed as workloads grow and the scale, especially with day two operations. I mean, there's a big challenge trying to meet strict business SLAs for performance, trying to manage rapidly growing databases, trying to make sure that these database backup fits within the backup window, that we don't impact the system performance, we don't impact any kind of metrics, that we meet the SLAs, we meet the RTOs and RPOs. These factors typically they force DBS to delay virtualization of their business critical databases and workloads, right? And tack on to that the fact that you have cloning, you have refreshing operations as well, that every DBA he or she would have to do as part of the day-to-day life. That further complicates matter. So what VMware Virtual Volume, or vVols as we call that, they address the challenges of day-to-day operations, including the backup, including the recovery, the cloning and database provisioning, and so on and so forth. And you are able to use vVol as a mechanism, right, when we go into database as service, or when we go into any of the use cases that database as service provides, especially with provisioning databases, commissioning, decommissioning, cloning, refreshing, right? If you have to patch, or let's say if you have to do metering or reporting, or if you have to add nodes, or if you have to remove nodes from a rack cluster. And there's a link in the bottom of the slide that essentially is the reference architecture, and that basically validated any of the day two operations of both single instance database and Oracle RAC on vVol using pure storage, flash array, X50. Some of the use cases that we covered were backup and restore, cloning, refreshing, patching, and so on and so forth. Next slide, please. All right, so in conclusion, there are a couple of resources that we have put up here. Essentially, that's the one-stop shop where anything and everything to do with Oracle on VMware, including licensing, including virtual volumes, persistent memory, PBRDMA, best practices, Oracle RAC guide, everything can be found there. We also have a VMware vVol resource pages, the link as well at the bottom of the slide. Next slide, please. But I think we are at the end of our session here. So thank you, and thank you for listening to us.
Thank you very much. Appreciate your listening to us.